minus 3, 2, 1. Ignition and liftoff of Juno on a trek to Jupiter.
August 2011. NASA launches the Juno spacecraft. Its mission: to unlock the secrets of our solar system's biggest planet, Jupiter. How did this gas giant form? What powers its violent storms? What can the oldest planet tell us about the formation of our solar system and us? Now, after a 5-year journey, Juno is on the brink of discovery.
All stations on Juno Accord, we have the tone for burn cutoff on Delta B. Welcome to Jupiter.
And we're in. So we're there. We're in orbit. We conquered Jupiter. And now the fun begins. The science.
It's the largest planet in the solar system. But Jupiter remains an enigma.
Even though we've been studying Jupiter for hundreds of years, we still don't know some pretty basic things about it. We see these jet streams moving back and forth across Jupiter's atmosphere at hundreds of miles an hour. But we don't really understand what drives them.
We don't know how it's built, how the structure works inside.
We think down in the center there should be a dense core, but we don't have any direct evidence that it exists.
Maybe most important, we don't know how Jupiter was made.
Jupiter lies 500 million miles from Earth. But unlike our world, this gas giant remains virtually unchanged since the solar system formed. It's an archaeological treasure trove, the key to unlocking some of our most enduring questions.
How did the Earth get formed? Where'd the elements come from that made up life itself? That's one of the things Juno's seeking to answer.
Jupiter formed around 4.5 billion years ago with the rest of the solar system.
And as that process happened, there should have been a sort of donut-shaped cloud of gas and dust surrounding the forming sun that collapsed to make the planets. First Jupiter, and then the others.
Over time, the planets swept up vast amounts of original material, growing into a giant.
Jupiter, all by itself, is more than twice the mass of all the other planets combined.
It's huge. Everything in the entire solar system, all the planets, all the asteroids, all the comets would fit inside of Jupiter.
The billion-dollar Juno mission is armed with some of the most advanced technology ever engineered.
Our camera, JunoCam, will take great pictures. Our ultraviolet camera will take ultraviolet images and see the aurora. The infrared camera will take pictures over the pole. And of course, all the other instruments will get a chance to observe Jupiter on every orbit.
Getting close enough to help unlock Jupiter's elusive secrets is fraught with danger.
In some ways, Jupiter is the most dangerous place in the solar system to fly a spacecraft.
This image reveals what Juno's up against. Intense belts of radiation, swarming with high-energy electrons, seen here in red.
These electrons just eat electronics. They just will kill the spacecraft. So Juno has a radiation vault where all the sensitive electronics are shielded behind walls of titanium.
It's sort of like we're sending an armored tank to Jupiter.
If you were sitting outside of this vault on our spacecraft, by the end of the mission, you would have gotten the equivalent of about 100 million dental x-rays, which would be like sitting in a dentist chair, getting an x-ray once a second, every second, for a bit over 3 years. But inside this vault, you'd only be getting the equivalent of about a day and a half or so. Not too bad.
To help protect Juno, the spacecraft will be placed in a polar orbit that avoids the deadliest radiation belts at the equator. And by orbiting pole to pole, Juno will reveal the whole planet like never before.
If you look at our current maps of Jupiter, the North and South Pole are just kind of a blur. Because Juno's in a polar orbit, for the first time, we'll get a good look at the North and South Pole of Jupiter.
Juno is on a suicide mission. It won't survive Jupiter's lethal radiation forever. But it's hoped the spacecraft can last for around 2 years, building up the most comprehensive profile of Jupiter ever. From its violent birth billions of years ago to the colorful kaleidoscope of storms we see today. On arrival, Juno will come face to face with Jupiter's violent weather.
Jupiter's weather is the most dynamic in the entire solar system. Its atmosphere is filled with these incredible zones and belts moving in different directions and at different speeds, creating storms that last over 300 years, like the Great Red Spot. This is real turbulence.
The Great Red Spot is massive. It rises 5 miles above the cloud tops and could swallow 2 Earths. But what drives it?
It looks a little bit like a hurricane on the Earth, but it must work in a different way because there's no ocean or land underneath it, which is what we have on the Earth.
Jupiter's storms cover vast areas, but exactly how deep they go isn't known. Using a unique set of instruments, its microwave radiometers, Juno will measure energy emanating from beneath the cloud tops, revealing for the first time the weather conditions hundreds of miles below, seeing if the storms are deep-seated or relatively shallow. Juno's radiometers will also play another vital role, unlocking Jupiter's chemistry.
The global water content of Jupiter is one of the most important numbers we can measure with the Juno spacecraft.
Scientists know Jupiter contains water, but exactly how much remains a mystery. By finding an answer, Juno hopes to solve a great scientific puzzle. How much water ice was involved in forming the planets?
We know this is important because we're still trying to explain how did Earth get its oceans? We don't really know.
Jupiter's a time capsule. It preserves the original ingredients from which all the planets formed.
If Jupiter formed from large chunks of ice that collided together and stuck until you had enough gravity to pull in all the other material, then you'd expect a large amount of water from that ice. Or if it formed from the initial cloud of gas and dust and it wasn't the ice at all sticking together that made the planet, all of those things would give you a different measurement for how much water there is in Jupiter.
If Juno discovers Jupiter is relatively wet, then water ice must have played an important role in planetary formation and could explain Earth's oceans. But if Jupiter is relatively dry, scientists will need another theory to explain how the Earth became a water world teeming with life. At almost 500 million miles from the Sun, Juno must survive on just 4% of the amount of sunlight the Earth catches. Powering all of Juno's instruments is not easy. The spacecraft relies on 3 giant 29-foot-long solar arrays. It's the furthest from the Sun this technology has ever been tried.
The reason these solar arrays have to be so big is Jupiter is 5 times farther away from the Sun than the Earth is. So these arrays have to be so big just to give us about 500 watts of power.
On Earth, heat from the Sun drives our weather. But Jupiter lurks in the dark. So what powers its ferocious storms?
Jupiter's really far away from the Sun, so it must be driven by something very different.
The answer lies with its size.
So Jupiter has this enormous amount of heat generated when it formed. Now, billions of years later, it's still generating heat because it's still very, very slowly collapsing, a centimeter or 2 a year.
Juno will sense this heat, welling up from below, hopefully answering if it's this energy that powers the solar system's most dynamic weather. What lies deeper within Jupiter is even more mysterious. Scientists think below the clouds is one of the weirdest places in the solar system, where unearthly metals form under the planet's crushing weight.
The pressure is so high, the conditions are so intense that you take that gas and you squeeze it down so much that it becomes a liquid.
Down here, Juno might detect a layer where skies rain not water, but liquid hydrogen. Descend even deeper, and the big squeeze continues, creating an even stranger substance.
Well, about a third of the way in, you're getting to a pressure that's something like 2 million times the pressure here on the Earth. And that's a key number because that's about where hydrogen gas becomes a metal, liquid metallic hydrogen.
Here, Juno may discover a vast metal ocean, perhaps the largest ocean in the solar system. Finally, we reach the core. Here it's thought the crushing pressure peaks at a staggering 650 million pounds per square inch. The equivalent of being under a pile of cars over 100 miles high. Under such extreme conditions, what lies here is anyone's guess.
We have no idea even how hydrogen behaves at such a pressure. And maybe there's a core of heavy elements down deep at this very level. That's one of the things Juno's seeking to answer.
Whatever Juno discovers, it's down here that Jupiter generates its most dazzling feature of all. A magnetic field, much like the Earth's, flows from pole to pole. But like everything else on Jupiter, it's enormous.
Jupiter has the largest magnetic field in the entire solar system. In fact, Jupiter's magnetosphere is the largest structure in the entire solar system.
10 times more powerful than Earth's magnetic field, it creates some of the brightest lights in the solar system, Jupiter's aurora.
On Jupiter, the aurora are bigger than the whole Earth. They're caused by particles streaming down the magnetic field lines, hit the upper atmosphere, and it glows.
Juno's unique polar orbit will provide the perfect position to study these particles and the brilliant celestial fireworks they create. Juno arrives at Jupiter on the 4th of July, hopefully giving scientists something extra to celebrate as the spacecraft ushers in a new, exciting chapter in our understanding of the solar system.
I think maybe one of the most fascinating questions that Juno is trying to answer is, what's the recipe for solar systems? If we can help just answer that one question, that would be so great.
How did the whole solar system form? Where do we come from? How did we get here? To me, that's the big, important part of the Juno mission, is that we're going to try to understand something much larger than ourselves by trying to understand the largest planet in the solar system.